Hello, everybody. Thank you so much for listening to our presentation. Our topic is about don't get kicked. This is the topic that we found from a Kaggle website, and we got all the data from that website. My teammate Wendy and myself, Negin, were working on this project, and this is for data mining project. The whole idea about this project is when car dealers are going to the auctions and they want to buy their car, how they can figure out if the car that they want to buy is the good car or if it is not a good car. The term that the dealerships are using is if the car is the kick car or if it is not the kick car. So definitely some cars that are kick car, they have some serious damage in their record. So the purpose of this project is to apply some modeling in order to predict if the car is the good car or the not kick car or if it is the kick car. Definitely, before applying any modeling, we need to have better overview about the data, how the data is distributed. So we use these libraries and import them to figure out how the data looks like. This slide and the next one shows that we have 34 columns. So out of these 34, 33 columns are the features of our data, and the last column is our classes, which is a yes or no. So this is the binary classification. It gives that the labels are yes or no. Yes means the car is key car, no means the car is not the key car. So you can see that we have, for example, reference ID, one of the feature. We have auction, vehicle year, vehicle age, the make of the car, model of the car, and some other features. The total will be 33 and one for the like if the car is the key car or not. So before continuing, it's important to do some transformation and feature engineering. The most important one is it's better first to check if we have any missing value in any feature or not. So we wrote some code to find out how much percent of the data in each feature is missing. You can see that these two feature has like 95% missing value. That's too much. So without losing any information from our data, we can remove these two features. Or for example, we can see that we don't need any reference ID. Reference ID is just to show the orders or somehow the orders of the cars. So we don't need the reference ID. We can remove it. Or for example, we can see that for some of the features like the transmission, it's like about 0.012%, and we can this is the amount of the like missing value. So we can replace them by the zero, which is one of the categories. So there are a lot of transformation here for the features that are that have the missing value. For some of them we can replace them by the most frequent category. For some of them we can remove them without losing any information, and for some of them we can replace them by the like the median of the values in that feature. So it depends on the how much it is missing and like the distribution of the whole feature. We can find out what to do for that specific feature. So also, another important thing is to figure out which feature has numerical value and which feature has the categorical or non-numerical value. You can see that these are the features has numerical value, and these are the features that has like categorical value. And we can apply label encoding technique to convert all categorical feature to like numerical value, because if we don't convert them, definitely we don't have any value for those specific categorical features, and we cannot do any classification or any other type of modeling. In this step we try to see to have some data exploration. We wanted to see how different classes are distributed. We can see that about 90.43% of the classes are a bad boy, or it is a kick car, and just about 9% or almost 10% is a good car. So it's not like a balanced data. We can have some exploration over the features, and we can see like the distribution of a feature called make over like different classes. We can see that first of all, the number of cars in each feature is not the same, or even not more similar. And we can see that, for example, for some cars like Volvo, almost all of the car was the bad boy, and for some cars like Infinity, almost all of them was the good guy. Or we have another data exploration for the vehicle age, and another one for the size of the car, and another one for the nationality of the car. The next step before doing any modeling is to split the data into training and testing. Definitely, so one of the factor that we have is like splitting 20 to 80, like 20% for testing and 80% for the training. This is one of the techniques that avoid overfitting. And because we have unbalanced data, it's good to apply upsampling method for the training data. For our modeling, because we have label encoding on our data, definitely we need to use nonlinear classification. So we apply AdaBoost classifier with decision tree as the base for this classifier. So this type of classifier has some weak classifier, and the combination of all of them will give us the final weight, and will give us the final results. So definitely, because we have several weak classifier, the results would be very strong and powerful. We are trying to apply a random forest classifier and SVM if we have time as the nonlinear classifier, and compare the results of all of these prediction and see which one give us the better results. Also, it's good to tune hyperparameters and use the cross validation to give us the better hyperparameters. For the evaluation, we apply definitely confusion matrix is a great evaluation. So which also the area under the curve, F1 score, and accuracy, these are all factors that give us if our like modeling is good, or we need to do better modeling. So you can see that the purpose of this project is to predict if the car that was purchased at the auction is the key car, or if it is not and it's a good car. And definitely we are trying to figure out which cars have a higher risk of being a kick. So the value of this project is that our study can provide a real value to dealerships who are trying to provide the best inventory selection possible to their customers. And this is the list of our references. Definitely we will have more references for next steps. Thank you so much, and appreciate. Have a great day. Bye.